video, we are going to apply the second derivative test on more complicated function. So let's take a look at number 4. So number 4, we have f of x equals to the square root of x squared plus 1. What is the domain of this function? We have a square root, right? Then we have to pay attention to the stuff inside the square root. So the square root of negative is undefined, right? We have to pay attention to that. Can x squared plus 1 be negative? The answer is no. You square a number, so after you square any number in the row, you square a number, the number is either 0 or greater than 0. You add 1 to it, it's sure positive, so the domain is from negative infinity to positive infinity. So you can plug in any number you want to the function. Alright, so let's take the first derivative using chain, right? So 1/2 and then x squared plus 1, 1/2 minus 1, and then you take the derivative of the radicand, so x squared plus 1, the derivative is 2x, and then you have f double prime of x, that is equals to x divided by the square root of x squared plus 1. You set the first derivative equals to 0, and then you solve for x, so we are going to take the top divided by bottom. Think about this, a divided by b must be equals to 0, so that means a has to be equals to 0, right? So x, the top, the x right here, this x equals to 0, so this is my critical number. Can the denominator be equals to 0? Do we have, that means do we have to worry about that when x equals to a certain number, the function is not differentiable? The answer is no. X can be anything you want, right? So even though you consider the bottom, x squared plus 1, it can never be equals to 0. Yep, x plus 1 is never equals to 0, so there is nothing to worry about. So in this problem, x equals to 0 is my only critical number. And then you proceed to the second derivative. So the second derivative, you have to use the quotient rule, right? So you know how I do my math. Every time I say you have to use quotient rule, I will just remind you what quotient rule is. That is gf prime minus fg prime, and then divided by g squared. So f double prime, so I square the bottom immediately. So that is the square of x squared plus 1, I square the bottom immediately, and then gf prime, so the square root of x squared plus 1, the derivative of the top is equals to 1, and then minus for the quotient rule, and then f, the derivative of the bottom, so that is 1/2 x squared plus 1, and then raised to negative 1/2, and then the derivative of x squared plus 1 is equals to 2x. Okay, and then we simplify the second derivative. So the second derivative is equals to fraction bar. After you square the denominator, the square root no longer exists. And then this is the square root of x squared plus 1. And then minus. So what do we have in the second derivative? So in the second derivative, we have the 2 got cancelled, so basically we have this right here. So second we have it's not just an x, so here is another x, right? So here is an x, so here is an x, so basically we have an x squared, and then the 2 got cancelled, and then we have the square root of x squared plus 1. Okay, so now the math is, the second derivative is done, and then according to the second derivative test, we have to plug in the critical number into the second derivative to see if that is concave up or concave down, right? So we have f double prime of the critical number, so that is 0 plus 1, and then minus 0, so that means the whole thing is 0, and then divided by 0 plus 1. So basically this is the square root of 1 minus 0 divided by 1. So we have a 1 divided by 1, that is equals to 1. 1 is greater than 0. So greater than 0. So now I am showing that I understand the concept of second derivative test. So since the second derivative is positive at x equals to 0, so that means when x equals to 0, the function is concave up. What is concave up look like? Concave up looks like this. And then what is 0? 0 is a critical number. That means 0 is either a min or a max. So x equals to 0 right there at a concave up status. This point is local minimum. So that is how second derivative test works. All right, so we don't need to bother the sign chart anymore. So now I am going to plug in 0 back to the original function. We have 0 squared plus 1, and then that is equals to 1. So that means when x equals to 0, y equals to 1, this order pair is a local minimum. Okay, the problem is done. Let's answer the next one. The next one takes a lot of work, and that's why I picked that problem. So moving on to the next one, I'm going to switch color for that. Number 5. So let's put it right here in case you are still writing this down. So we have f of x equals to 2 times sine of x, and then plus cosine of 2x. So this one, they are focusing on the domain from 0 to 2 pi. Okay, so first derivative, f prime of x. So this is equals to 2 cosine x. And then the derivative of cosine is negative sine, right? And then we have a 2x, a linear function inside cosine. What is the derivative of 2x? The answer is just a 2. This is using a chain rule. We have to set this equals to 0. We have to set this equals to 0. That is a lot to do. We have a cosine, we have a sine of 2x. I cannot just solve for x like this. We have one expression equals to 0. We have trigonometric function in here. I can only handle one trig function at a time. That means you have to rewrite sine of 2x using double angle formula, sine of 2x. This one is a double angle formula that equals to 2 sine x cosine x. You don't have to look it up. I got it right there for you. So this is a 2 cosine x, and then minus 2 times 2 sine x cosine x equals to 0. All right. And then we multiply the 2. Cosine x equals to 0. Oh, let me take this back. I didn't mean that if we have a sine and a cosine and a sine 2x, we can solve for x. This is a sine of 2x. I can't just solve for x like this. So we have a cosine, we have a sine of 2x. If I just factor out the 2, that is not helping me at all. So factor out the 2, then you have cosine x minus sine x equals to 0, right? That doesn't help you at all. You can try factor out the 2 to see if you can solve for cosine x minus sine 2x equals to 0. I'm sure the answer is no. You cannot solve it unless you use a double angle formula to rewrite the sine of 2x. The next step is I am going to factor out the 2 cosine x. So after that, we only have 1 minus 2 times sine x equals to 0. So when you apply 0 product property, you have 2 cosine x equals to 0, 1 minus 2 sine x equals to 0. See, we take care of one trig function at a time, divide both sides by 2. We have cosine x equals to 0. So from 0 to 2 pi, that means you look at your unit circle. You look at one full circle only from 0 to 2 pi. Cosine x equals to 0. So when x is equals to 0, we have to pick a point on the y-axis, which is x equals to pi over 2, and then 3 pi over 2. They are both critical numbers. And then this one is sine of x equals to 1/2. So sine refers to y. Look at your unit circle. When y is equals to 1/2, there are two x coordinate, x equals to pi over 6. There are two angles. I should use the word angles. 5 pi over 6, and these 4, they are my critical numbers. All right, And then you do the second derivative. Where is my first derivative? My first derivative ends right here, right? My first derivative ends right here, so that means I am going to bring this down to my second derivative. So what's the second derivative? F double prime of x, that is equals to, the derivative of cosine is negative sine, so that's why there is a negative, and then the derivative of sine of 2x, so that is cosine 2x, but that produce an extra 2, that 2 times the 2 over there is equals to 4, using chain rule. And then what do we do? The next thing that we will have to do is I am going to plug in every critical number to the second derivative to determine concave up or concave down, because they are critical numbers. So that means when x equals to one of these value, you either get a mean or a max. So here is what I am going to do. F double prime of, let's start with the smallest value, pi over 6. So that is equals to 2, negative 2, times sine of pi over 6, right? And then minus 4 times cosine, 2 times pi over 6. We have to determine what that equals to. So here is how we are going to do it. I don't want to write everything out because that will make the video so long. So we are going to plug in every one of this into my second derivative. So first we plug in a pi over 6. Pi over 6. So this one is equals to negative 3. Negative 3 is less than 0. Less than 0 means concave down. That means at that point we have a maximum. And then let's plug in the pi over 2. And then f double prime of pi over 2. So all you have to do is you change that to a pi over 2. You change that to a pi over 2. So that gives you a 2. This is greater than 0. Greater than 0 means concave up. At pi over 2, we have a minimum. Keep going. And then f double prime, let's try the 5 pi over 6. So that means you have to replace the pi over 2 by 5 pi over 6. This one is by 5 pi over 6. So one question that you want to ask me is, hey, this math, since you don't really care what this value equals to, you don't care about the exact value. All we care is that positive or negative? Because positive is concave up, negative is concave down. I don't need to get the exact value. Now, the question that you want to ask me is, hey, can we just use a calculator to expedite this process? Absolutely yes. So when you do this in your calculator, make sure you use radian mode. Radian mode, okay? You hit the mode key and then you make sure the mode is in radian, all right? Mode key, make sure the mode is in radian. Plug in a 5 pi over 6, you will get a negative 3 that is less than 0, which is concave down, then we have a max. And then the last number we have to find out is the 3 pi over 2. So you change that to a 3 pi over 2, and then you change that to a 3 pi over 2, so that gives you a 6. 6 is greater than 0, so that is concave up, then we have a minimum. Now, you just determine the mean and max for each critical number. Can you tell me the exact location, right? It's like looking something through Google Map. You got a location, can you tell me the exact location? That means can you give me the address to find the restaurant or that shopping center? Okay, to find the exact location, we have to plug it in to f of x. So we have to find f of pi over 6. So what is f of x? F of x is, I can read the function to you, that is 2 times sine of x, and then plus cosine, and then 2 times x. Okay, so you plug in pi over 6. So this is a pi over 6, this is a pi over 6, so that gives you 3/2. So that means pi over 6, 3/2. You just got the answer right here. So that is a local max. And then you have to do this for the pi over 2, 5 pi over 6, and 3 pi over 2. So f of pi over 2. And then you have to find f of 5 pi over 6. And the last one, f of 3 pi over 2. Okay, so all you have to do is you replace these numbers to pi over 2, pi over 2, 5 pi over 6, 5 pi over 6, you write the rest for me. And then 3 pi over 2, 3 pi over 2, the rest won't change. This is still 2 times sine of that, and then plus cosine, and then 2 times sine of that. Oh, this one, good question. This one, can you use an approximation? This number is nice, but the numbers, they are not always nice. The last step, I will say you really have to use your knowledge back from trigonometry to get the exact value. Read the problem carefully. Again, read the problem, especially if you are doing your homework online. You got to read the problem. If they ask you to provide exact value only, then you have to provide exact value. If you give them a decimal from your calculator, you are lazy, then you don't get any credits. Again, read the problem carefully. Are they looking for exact value, or they just accept approximation? 99% of the time, they want exact value, because if someone gives you this on the test, that person want to push you to use your knowledge you learn in trigonometry. All right, so this is equals to 1, this is equals to 3 half, and then the last one is equals to -3. So each of this is a order pair. 5 pi over 6, 3 half, and then 3 pi over 2, -3. So this is a local max, this is a local min, this is a local max, this is a local min. This is from here, the conclusion that we made in there. All right, so that is the end of this problem. If you think my video is helpful to your learning, subscribe, give me a like, share these videos out to your friends on our social media. I see you all in the next lesson.